Slide 1. Human Activities and Climate Change 1. Greenhouse Effect. Natural greenhouse gases, carbon dioxide, water vapor, methane, and nitrous oxide. Mechanism. The sun emits shortwave radiation, the earth absorbs it and re-emits long-wave infrared radiation. Greenhouse gases absorb and re-emit that infrared, trapping heat and warming the earth. It's needed for life. It keeps the earth at around 15 degrees Celsius. Without it, Earth would be about minus 18 degrees Celsius. 2. Human activities increasing greenhouse gases, burning fossil fuels. Coal, oil, gas plus oxygen produces CO2 and water. For example, methane plus 2 oxygen gives carbon dioxide plus 2 water. Deforestation, less photosynthesis means less CO2 absorbed, and burning trees releases CO2. Agriculture, rice paddies and cattle belching release methane. Nitrogen fertilizers release nitrous oxide. Landfill decomposition releases methane and CO2. Industry, cement production. Calcium carbonate produces calcium oxide plus CO2. Data, CO2 is about 0.04% and rising. Methane is rising too. 3. Climate change, effects and evidence. Enhanced greenhouse effect leads to global warming. Evidence, global temperature records rising, ice core data showing CO2 in temperature correlation, sea level rise data, shrinking ice caps, ocean pH data showing ocean acidification. Effects, sea level rise causes coastal flooding, extreme weather is more frequent, and ocean acidification, CO2 plus water gives carbonic acid, which releases H plus ions and lowers pH, affecting coral and marine organisms and causing shell dissolution. Also changes in rainfall, loss of biodiversity, and species migration. 4. Carbon footprint and mitigation. Carbon footprint, the total CO2 equivalent of an activity. Mitigation, reduce fossil fuels, use renewables, wind, solar, hydro, nuclear. Carbon capture and storage, capture CO2 and store it underground. Planting trees so photosynthesis absorbs CO2. Low carbon transport like electric cars. Reduce meat consumption for less methane. Recycle and reduce waste. Carbon neutrality means net zero. Balancing emissions and removal. 5. 6-mark skeleton and evaluation structure. Explain the natural greenhouse effect and name the gases. Explain how human activities increase greenhouse gases with equations. Give evidence. Ice cores, temperature records, sea level. Give effects, sea level, acidification, weather. Evaluate mitigation, pros and cons. Evaluation, cost, scalability, public cooperation, political issues. Limitations. Models are complex. Correlation doesn't equal causation, but there's strong scientific consensus. Keywords, combustion, photosynthesis, carbon cycle, greenhouse gas, global warming, carbon footprint, CCS, renewable. Slide 2, atmospheric pollutants 1. What are atmospheric pollutants and sources? Definition, gases and particles that pollute air from combustion of fossil fuels. Carbon monoxide, sulfur dioxide, nitrogen oxides, NO and NO2, particulates, and unburnt hydrocarbons. Sources, incomplete combustion gives CO, soot, and hydrocarbons. Sulfur impurities in fuels give SO2. High temperature in engines. Nitrogen plus oxygen gives nitrogen oxides. 2. Formation equations, nitrogen oxides. Nitrogen plus oxygen gives 2NO at high temperature. 2NO plus oxygen gives 2NO2. Sulfur plus oxygen gives sulfur dioxide. Complete combustion, methane plus 2 oxygen gives CO, 2 plus 2 water. Incomplete combustion, CO, 2 methane plus 3 oxygen gives 2 CO plus 4 water. Incomplete combustion, soot, 2 octane plus 17 oxygen gives 16 carbon plus 18 water. 3. Effects. Mark scheme. Point CO is toxic, binds to hemoglobin, preventing oxygen transport. SO2 and NOx cause acid rain and respiratory problems. Acid rain formation, 2SO, 2 plus O2 gives 2SO3. SO3 plus water gives sulfuric acid. 4. NO2 plus 2 water plus oxygen gives 4 nitric acid. Effects of acid rain: kills aquatic life, lowers pH of lakes, damages trees and forests, erodes limestone. Calcium carbonate plus sulfuric acid gives calcium sulfate plus CO2 plus water. Particulates cause global dimming, respiratory and lung damage, and blacken buildings. NOx contributes to photochemical smog and respiratory irritation. 4. Reducing pollutants. Methods: catalytic converters in cars. 2CO plus 2NO gives 2CO2 plus nitrogen. 2CO plus oxygen gives 2CO2. Low sulfur fuels. Remove sulfur from fuel for less SO2. Flue gas desulfurization. Calcium carbonate gives calcium oxide plus CO2. Calcium oxide plus SO2 gives calcium sulfite. Calcium sulfite plus half oxygen plus 2 water gives calcium sulfate dihydrate. Gypsum. Electrostatic precipitators remove particulates and soot. Renewables, electric cars, carbon capture. 5. 6-mark skeleton. Compare complete versus incomplete combustion, products and pollutants. Name pollutants and sources: CO, SO2, NOx, particulates, hydrocarbons. Write balance formation equations. Explain effects. Toxic CO, acid rain from SO2/NOx, global dimming from particulates. Methods: catalytic converters, low sulfur fuel, FGD, renewables, electrostatic precipitators. Evaluation: CO is still toxic. CO2 is a greenhouse gas. Methods are costly. Slide 3, evolution of the atmosphere 1. Early atmosphere, around 4.6 billion years ago, formed by volcanic activity. Main gases: about 95% CO2, water vapor, nitrogen, small amounts of methane, ammonia, hydrogen, almost no oxygen. Describe: intense volcanic activity released gases. 2. Formation of oceans and CO2 decrease. Stage 1. Earth cooled, water vapor condensed, oceans formed. CO2 dissolved in oceans. CO2 gas becomes CO2 aqueous. Dissolved CO2 form carbonate precipitates. Calcium ions plus carbonate ions gives calcium carbonate. Limestone. CO2 locked in fossil fuels, coal, oil, gas, and sedimentary rocks. CO2 levels fell. 3. Photosynthesis and O2 increase. Stage 2. Cyanobacteria and algae evolved around 2.7 billion years ago. Photosynthesis: 6CO2 plus 6 water gives glucose plus 6 oxygen. CO2 decreased further, oxygen increased. Oxygen allowed the evolution of plants and animals. Ozone layer formed. 3 oxygen gives 2 ozone, using UV light, protecting from UV. 4. Today's atmosphere: 78% nitrogen, 21% oxygen, 0.94% argon, 0.04% carbon dioxide, trace noble gases, and water vapor. Key: nitrogen 78%, oxygen 21%, argon around 1%, CO2 0.04%. 5. 6-mark skeleton and evidence structure. Point 1. Volcanoes produce the early atmosphere. CO2, water vapor, nitrogen, little oxygen. Cooling leads to condensation, oceans form. Point 3. CO2 dissolves, forms carbonates and fossil fuels. Point 4. Photosynthesis increases oxygen, decreases CO2. Point 5. Ozone formation. 3 oxygen gives 2 ozone, protects from UV. Evaluation: limited evidence. Composition of the early atmosphere is inferred from volcanoes today. Proportions aren't certain. Slide 4. Combustion and the atmosphere, full mark scheme. 1. Earth's atmosphere evolution. Early atmosphere. Volcanoes released CO2, water vapor, nitrogen, little oxygen. Oceans formed as Earth cooled. CO2 dissolved. Photosynthesis by algae and plants produced oxygen. CO2 decreased, oxygen increased. Today's atmosphere: 78% nitrogen, 21% oxygen, 0.04% carbon dioxide, around 1% argon, and noble gases. Trace water vapor. 2. Complete versus incomplete combustion. Complete combustion: fuel plus enough oxygen gives CO, 2 plus water. For example, methane plus 2 oxygen gives CO 2 plus 2 water. Clean, maximum energy. Incomplete combustion. Limited oxygen gives CO plus carbon soot plus water. For example, methane plus 1.5 oxygen gives CO plus 2 water. Less energy produces toxic CO and particulates. General. Hydrocarbon plus oxygen gives CO2 plus water versus hydrocarbon plus oxygen gives CO or carbon plus water for incomplete combustion. 3. Pollutants from combustion. CO is toxic. Binds hemoglobin, reduces oxygen delivery. Particulates and soot cause global dimming and respiratory problems. SO2 from sulfur impurities causes acid rain. NOx from high-temperature nitrogen plus oxygen in the engine causes acid rain and photochemical smog. Acid rain, SO2 plus water gives sulfurous acid. 2SO2 plus oxygen gives 2SO3. SO3 plus water gives sulfuric acid. 4NO, 2 plus 2. Water plus oxygen gives 4 nitric acid. Effects: kills aquatic life, erodes limestone buildings, damages trees. 4. Greenhouse effect and global warming. Greenhouse gases, CO2, water vapor, methane, nitrous oxide. Infrared radiation is trapped and warms the earth. Enhanced by human activity. Burning fossil fuels increases CO2, deforestation, agriculture, methane from cattle, rice, landfill. Effects: sea level rise, climate change, extreme weather. Carbon footprint, total CO2 of an activity. 5. Reducing pollution. Catalytic converters. Exhaust gives cleaner gases. Low sulfur fuels. Flue gas desulfurization with calcium oxide or calcium carbonate. Calcium oxide plus SO2 gives calcium sulfite. Gypsum. Renewable energy, solar, wind, hydro, carbon capture and storage, planting trees to absorb CO2. 6. 6-mark answer. Skeleton. For describing the evolution of the atmosphere, start with volcanoes. CO2, water vapor, nitrogen, little oxygen. Cooling leads to oceans forming, CO2 dissolved. Photosynthesis, CO2 decreases, oxygen increases. For evaluating combustion effects, compare complete versus incomplete equations. Explain pollutants. CO toxic, SO2/NOx cause acid rain. Particulates affect health and environment. Link to greenhouse gases and global warming. Actions to reduce: catalytic converters, low sulfur fuel, renewables, trees, carbon capture.